Bismillahirrahmanirrahim. Assalamu alaikum. I'm Rashida here to present my presentation. My presentation topic is hyperconjugation. Hyperconjugation is a key concept in organic chemistry, and in this presentation, we will discuss how hyperconjugation affect the stability of a molecule and the reactivity of a molecule. Okay. Uh, the most important things are we can say that in order to understand the concept of hyperconjugation, we must know about two important terms. The first term is sigma electrons and the second is pi electrons. Now, what are sigma electrons? Sigma electrons are the electrons that are involved in the formation of a sigma bonds, and they are formed by head-to-head overlapping of atomic orbitals. Okay, you can see in the example, the sigma bond is formed by the head-to-head overlapping of atomic orbital. The second important term is pi electrons. The pi electrons are the electrons that are found in pi bonds, and they are formed by side overlapping of atomic orbitals. Okay, and the pi bond is also shown in the example, formed by side overlapping of atomic orbital. Okay, let's consider another example of a organic molecule showing the sigma electrons and the pi electrons. We know that this is an alkene molecule that contains a double bond, and we know that the double bond contains one pi bond and one sigma bond, and it is obvious that the pi bond contains pi electrons and the sigma bond contains sigma electrons. Other than this double bond, there is also carbon hydrogen bondings, and these carbon hydrogen bondings are also considered as sigma bonds. Okay, now the second important concept that we must learn is about the alpha carbon and the alpha hydrogens. What is alpha carbon? Why it is called alpha? Okay, so the alpha carbons are the carbon atoms that are directly attached to a functional group, and the hydrogens that are directly attached to this carbon, this alpha carbon, are known as alpha hydrogens. We can see in the given examples. And the first example, I have alpha carbon, the carbon atom that is directly attached to the carbon that containing the double bond as a functional group, and this alpha carbon consists of 3 alpha hydrogens. And the second example, I have again alkene molecule, double bond as a functional group, and there are 2 alpha carbons attached to the functional group containing carbon atoms, and total I have 6 alpha hydrogens in this molecule. Now the important after learning about these important terms, then now it become easy to understand the concept of hyperconjugation. So how we will define the hyperconjugation? So hyperconjugation is actually the shifting of sigma electrons to adjacent vacant or partially filled p orbital in order to increase the stability of a molecule. Let's consider an example of carbocation. So the positive charge on the carbon atom shows that there is a vacant p orbital, and we in order to stabilize this molecule, we have to fulfill the requirement of this empty p orbital, and this empty p orbital can be fulfilled in the presence of alpha hydrogen or the alpha carbons, okay, containing alpha hydrogens. And the sigma bonds, they another important need for the hyperconjugation. In this molecule, we can see that there are 3 alpha hydrogens. Means there are 3 possibilities of transferring alpha electron to the empty p orbital. Okay, in this carbocation, the hyperconjugation is possible. We can say that hydrogen has given its sigma electron to the empty p orbital, and hence there is no bond between carbon and hydrogen after the transfer of its electron to the empty p orbital. And the second possibility is that the other hydrogen atom may transfer its sigma electron or shift its sigma electron to the empty p orbital, and we get a new structure like shown in the example. And the third possibility is that the third hydrogen may transfer its electron to the empty p orbital, and we get another naive structure of the molecule with a stabilized form. So these three structures of these carbocations are known as resonating structures of the molecule. Now the most important thing that we must know about hyperconjugation is about the importance of hyperconjugation, how it's playing its role in the stability or reactivity of organic molecule or a compound. So hyperconjugation helps us to determine the stability of a compound such that the more there are alpha hydrogens, there is more hyperconjugation, and highly stable the molecule will be. Here I have taken an examples of different carbocations on the basis of the number of alpha hydrogens. As I already mentioned that if there is higher concentration or number of alpha hydrogens in the carbocation, it will be considered the most stable one as compared to the carbocation containing least or no alpha hydrogens. So in the first carbocation there are 3 alpha carbons, and these 3 alpha carbons contain 9 alpha hydrogens, and in the second carbocation there are 2 alpha carbons, and these 2 alpha carbons contain total 6 alpha hydrogens, and the third example there is 1 alpha carbon containing 3 alpha hydrogens, and in the last carbocation there is no any alpha carbon. It means there will be no any alpha hydrogen. So the alpha carbocation containing 9 alpha hydrogen is considered the most stable one, and the one containing no or least number of alpha hydrogen is considered as the least stable molecule. Okay, things to remember. Another important point that we must remember about hyperconjugation is that hyperconjugation is also known as no bond resonance and sigma pi resonance. Why hyperconjugation is known as no bond resonance? What is the reason behind that? Hyperconjugation is known as no bond resonance because there is no bond between carbon and hydrogen atom after the transfer of its electron to the empty p orbital. We can see in the example that before the transfer of its alpha electron to the empty p orbital, alpha hydrogen has a carbon has a sigma bond between the carbon and hydrogen, but after the transfer of or after the shifting of its electron to the empty p orbital, now the bond is broken and there is no bond between these two atoms. This is why it is called no bond resonance. Okay, why hyperconjugation is known as sigma pi resonance or sigma p resonance? The reason is that sigma electrons are shifted to a vacant p orbital. Okay, you can see in the given example that the sigma electron of the hydrogen, alpha hydrogen, is shifted to the p or pi orbital of the carbon. Due to this shifting of electron, resonance occur. Therefore, we can say that hyperconjugation is also known as sigma pi resonance or sigma p resonance. So this is all about my presentation. Thank you so very much.